So hi guys, welcome back to my YouTube channel. So in the previous videos, we have been talking about different methods of solving system of equations. We did method of substitution. Then we also learned the method of elimination to solve a system of equations. Now we want to talk about some special cases. In this video, I'm going to talk about the type 1, and then here we have three types. So we're going to talk about type 1, which is something that we have seen previously, and then later we'll talk about type 2 and type 3. So guys, to understand these special cases, it would make sense to actually look at some examples. So I have an example right here, which you can see up here. So the idea of this whole special cases again is based on the solutions. Okay, so if you look at these two equations, you may think of your own way of solving for the variables. Here I'm going to use the method of elimination. You can also use method of substitution if you like. It seems easier for me to actually use the method of elimination here. So let us go ahead and try to solve this, and from there then we will be able to explore if there's anything special about this equation. And then I would also like to bring in the visual piece of it. I won't be able to actually graph them exactly here because I don't have the graphing paper or I don't have the grid here. But if you have a graphing paper, you can actually go ahead and graph these, so you will be able to see an exact representation for these equations. But I'm going to roughly sketch the graph, and from that we are going to be able to see what is special about this equation and then the other two as well. Okay, so using the method of elimination, you can clearly see that if I add both of them, I would be able to eliminate the y values and then solve for x. So let us go ahead and do that. So I'm going to add them. So if I add them vertically, they're already aligned nice and fine. So it's 3x, this crosses out, and 5 plus 1 is 6. To get x by itself, I got to divide both sides by 3. What do I have? I get x equals to 2, so that's my x. And in order to find the other value, I can go back to either 1 or equation 2. Let us go to equation 2 here. So I have 2 times 2 plus y equals to positive 1. Let us go ahead and solve for y. I got 4 plus y equals to positive 1, subtracting 4 from both sides. We already know how to solve a simple linear equation. So y equals to negative 3. I have my ordered pair solution, 2 and negative 3. Guys, please make sure to verify this. I'm not going to do it here, but you should actually verify the solution as well. Guys, now you might think, what is so special about this? Well, there's nothing really special about this, but we want to start with this case, and then that would help us and build up to the other two. Guys, as I said, we want to think about this visually. And the visual representation of this graph, again, this is a rough sketch. So we have the x-axis and we have the y-axis, and one of the equations looks like this, has a negative slope, and the other one looks like this, has a positive slope. And what I'm trying to say here is that these two intersect at a point. And the idea of the solution, and when you think in terms of the graphs, is that the solution of a system of two equations is the point where the two lines intersect, right? So this point has coordinates 2 and negative 3. Now, when you have a scenario like this where you can find one solution, or in terms of graphs, it means that the two lines intersect at one point. Now, this has there's three ways of actually writing this. One is, you can think of this as having a unique solution, which makes sense. It has only one solution, though that's the only solution that is going to work. The second way of actually writing or thinking about this equation that you will see in the textbooks and other places where you see the system of equations, it is called independent system. And which kind of here means that the two lines are they're independent of each other, okay? And then the third one is called, this is also thought of as a consistent system. Okay, guys, so one should actually remember these three things which are associated with this first case, where we have a unique solution, one solution, where the two lines intersect at one point. So we think of that as having a unique solution, or you think as a system, you think of that as a system of independent equations, or you can also think of that as consistent system. Okay, So that is type 1, which is something which we have done in the previous videos. In my next video, I'm going to talk about type 2, and then we'll cover type 3 as well. Okay, thanks.